Hello guys, my name is Syed Vesali and today our topic is algebraic algorithms. So addition of unsigned numbers. Adding two numbers using bits, we will add their binary form using the binary addition logic. We know that 2 plus 3 is 5, but computer does not know that 2 plus 3 is 5. Computer only understand the binary language, assembly level language. So what computer do? Computer will convert 2 and 3 into binary form and then store that result into binary form and then give it first to one as a decimal value. As like it add 10101 and 11011 and will give answer to 110000 in binary form. Now subtraction of unsigned numbers. Also computer does not know that 2 minus 3 is minus 1 and 5 minus 3 is 2. So subtraction of unsigned numbers, what is that? We take a two subtraction of two number, that is m and n. Now what is done that and there would be two cases. If m is greater m minus, if we do m minus 1 m minus n, and if m is greater than or equal to n, then what do? Then you have to do r's complement of n, r's complement of n and add it to m, as here we have taken that m equal to 72532 and n equal to 13250. So we what we have done that 72532 is greater than 13250. Then then we what we have do that we have read to r's complement of n and we have added to this, and whatever we will get that 159282, then this one is carry. So in this, when m is greater than or equal to n, we have to discard that and carry. So the result is 59282. And what the second case is of type that m is less than n. See, m is 13250 and n is 72532. So, so we know that result is in negative because m is less than n. There, so when what we have to do that n, the value of n. So we have to find out the r's complement of n and add to m. And now here n carry is 0. So here in whenever m is less than or equal to m is less than n, then we what we have to do that when we add m to the r's complement of n and whatever we got result. So that is not final result. The final result is negative of r's complement of that result. Okay. So we have got here minus 5928. Yeah, this is also data type. Now, addition and subtraction with signed magnitude data. What signed magnitude data refers to? That now a plus b. So we have given sign of a and sign of b already. So addition algorithm, and there are two types: addition algorithm and subtraction algorithm. And also it is multiplication algorithm is also. So in addition algorithm, what we have done that when we are doing addition, that when sign of the A and B, so sign of A and B are same. So what we have to do? We have to do add its magnitude, and we have to attach sign of A to the result. And when sign of A and B are different, so compare both the magnitudes and subtract the smaller number from the larger. Now in subtraction algorithm is also follows the same, that when sign are when that not same, no. When sign of A and B are different, then we have to take out the magnitude of both and attach the sign of A to the result. And when sign of A and B are identical, so compare the magnitude and subtract the smaller from the larger number. Okay. Now I have given some this example: addition and subtraction with sign magnitude. So see, we have to do addition logic. That and what is here? See, see, we have to do addition logic, and what is here? The sign of both the operand is same. So whenever sign of both the operand is same, we have to do addition and and so we have done addition a plus b, and sign is of a, that a as sign plus. So here now here in second part, so what, that we have to add plus a and minus b. So sign is different. So we have to do subtraction of a smaller number from the larger number. So a minus b. If here also it occurs three conditions, that when a is greater than b, when a is less than b, and when a is equal to b. So if a is greater than b, then if a is greater than b, then what happen? That plus a addition of plus a and minus b will give an a minus b. But a is greater, then a is greater than b. So sign of a. So in result we got sign of a. Now b is, if b is greater, so in result we got sign of b. Now both are equal, so we can tell that a minus b. Okay. Now, now let us take another example of negative and negative. Yes, this part, okay. Minus a and minus b. So addition of minus a and minus b. So what we will do, add, we will add both the, and sign is of largest number. So sign is of a or a largest number. So sign is of a, that is negative. Now here see another example, that we have to subtract minus a and plus b. So sign is different. So sign is different. So we will what do? Subtract each other, and sign is of greater number, as greater is a. If b is greater, then subtract and sign is of greater number. And when equal, mm, okay. So next, hardware implementation. So what is the hardware? So I have already told that what computer do when we are doing minus 3 plus 2 and minus 5 plus 3 and so on. So here A and B are two registered that we have take two operand A and B. So AS and BS, A register and B register. So what we are doing that we if we are adding B data, B register data into A register data, that is A plus B. That is we are doing that add A comma B, that in assembly level language. So we are adding B register data to A register data. So here in between mode control and input carry. So mode control and input query role very importantly. And this AVF, what is this AVF? AVS is add overflow flip-flop. Okay, so mode control will input in parallel adder will input carry, and it gives an output carry, that is called as E. Okay, so hardware algorithm, yes, this is main, that addition. In addition, if sign are same, then add, and sign are different, then subtract. Okay, and in subtraction, sign are same, then subtract, and sign are different, then add. Okay, so add operation, if we do a plus b, that a is urgent in a, and b is added in b. It means b is added to a. Okay, so when we are doing XOR of sign bit of A and B, then if we got XOR in as a zero, it means both sign are same. If both sign are same, that it would be addition will perform. Both sign are same, then it would be perform addition. So A plus B will add it to A, and then the any carry flag will occur, then carry flag will store into the overflow flip flop, and then it ends it. But what happen if XOR of sign bit of A and B register is equal to 1? Then it means that sign of this both bit is not same. Then we have to do subtraction. Sign are different than subtraction. Now here we don't do that a minus b. Okay, here here what will that if we write that a minus b, if in simply we write in day-to-day life that a minus b, but here we write what we have to do, we do addition of A and B. But how? If A minus B, that we have to do 2's complement of B. So what is 2's complement of B? That 1's complement plus 1. And 1's complement of B is B bar and plus 1. So we add A to the, we add 2's complement of B to the A. That is A plus B bar plus 1. And that is stored to A. And we, and then what? Overflow, and when, and we uh, of the overflow flip-flop, that is to 0. And now we will check that carry. What is carry? If carry equal to 1, then I have already told you that if carry equal to 1, then m is greater than or equal to n, that is a is greater than or equal to b. And if carry equal to 0, then a is less than b. So what we have to do if a is greater than or equal to b, then we will see for a, if a equal to 0, then as will be 0 and it will end, and a is not equal to 0, then it end, and result is in a and as, okay, obviously. And if a is less than b, then a complement store to a, and a will increment, and as complement will store in as, and then result is in a and is method. Okay, so I have told that there are two algorithm, that addition algorithm, subtraction algorithm we have learned. Now we will learn about multiplication algorithm. So we know that 2 into 3 is equal to 6, but computer doesn't know. Then computer will convert that number into binary and do operation and give us a multiplication. So the major method is about a Booth multiplication algorithm. So in Booth multiplication algorithm, we can also do the multiplication of bits, two negative numbers like my minus 9 and minus 13. Okay, so here Booth algorithm is used. Okay, now what is hardware implementation of Booth algorithm? So we have take two number like minus 9 and minus 9 and minus 13. Okay. So we are storing that two number in minus 9 to BR register and minus 13 to QR register. Okay. So what happened that minus 9 and minus 13 are multiplying. So we have given we also required an AC register. AC register called as accumulator register. Okay. So what BR register BR register value will go to the in parallel ladder as an input, then in AC register, and then multiply to the QR register as data is going to QR register. Now here there is sequence counter. Sequence counter. We have to do we have to at finally we have to do sequence counter to the 0. Okay, so we name the register as A, B and Q, AC, BR and QR respectively. Q1 designates, okay, this Q1 here, this is Q1, so Q1 designates the least significant bit of the multiplier in the register QR. An extra flip-flop Q1 plus 1 is appended to QR to facilitate a double inspection of the multiplier. Okay, uh, that I am explaining that multiplied is m and multiplier is q, and sequence counter, that is count to be 0. Count sequence counter is n. Okay, so we will run this program till when up to till not when sequence counter not occur to 0. Okay, so what we have to do, that AC 0, so we will what do that we have taken a two number. Okay, okay, see first flowchart, that when q0 and q1, okay, q0 and q1, it is a bit of multiplier. Okay, so when q0 and q1 is equal to 0 1, okay, so what will we have to do addition of a and m and then store to a, and then we have to do arithmetic shift right. Okay, and if q0 and q1 is 1 0 1 0, then we have to do subtraction of a and m, and then arithmetic shift right of a, q and qn plus 1. Okay, and if q0 and qn plus 1 is 1 1 or 0 0, then we have to do directly arithmetic shift right of a, qn and qn plus 1. Okay, we have to do up to till when sequence counter is not 0. So let us take an example. We have taken as a minus 9 and minus 13. So in BR, so minus 9, I have already told that we will not consider a minus 9. So we will convert 9 into binary number and then 2's complement of 9. That is called as a minus 9 binary number. Binary number of minus 9. That is BR. Okay, so this is 0 1 0 0 1. and we have taken a Qn plus 1 AC accumulator and QR 10011. Okay, so here initially what is happened that Qn, that is the least significant bit of QR. Okay, that is 1 and Qn plus 1 is 0, and the sequence counter is obviously 5 because 5 here we have a 5 bit. So Qn and Qn plus 1 is 10. So what we have to do? See, if 10, then subtract BR. So we will subtract BR to the AC. Okay, in AC. So we have done subtraction, and then what is the next step? Next step is arithmetic shift right. So it's arithmetic shift right of AC, QR, and Qn plus 1. So here in subtraction we will get 0 1 0 0 1. So arithmetic shift right. So we have shift this bit 0 1 0 0 and up to a Qn. So Qn plus 1 got at 1, and QR will got 1, and sequence counter will become a less 1, that is 4. Okay, first it have 5 and then 4. Okay, so last bit Qn and Qn plus 1 is 0 and 1. Okay, so 0 1. So what is 0? So in 0 1, what happen? That it take addition. So in this addition will occur. Okay, last bit is 1 1. So in 1 1 what about it? Directly arithmetic shift right happen. So arithmetic shift right of this AC Qn and Qn plus 1 will occur, and then sequence counter is at 3. Now Qn and Qn plus 1 is 0 1. So 0 1. So now in 0 1 what happened? That addition of A and M. So addition of BR and QR. So add AC, add BR to AC. Okay, then next step is sequence counter. Now the next step is arithmetic shift right. So we have perform an arithmetic shift right to AC Qn and Qn plus 1. Then we got 0 0, and in 0 0 arithmetic shift right directly, and then we'll at last we got a 1 0. So in 1 0 we subtract BR to the AC, and what happens? And then next step is arithmetic shift right of that result AC Qn and Qn plus 1, and sequence counter become 0, and the the data and the binary number we get in AC and QN. Okay, so binary number we get in AC and QN is a finally answer of this multiplication. Thank you.